In this module of Inferential Statistics, we will learn about types of study and hierarchy of evidence. Now, first let's look at the sampling method. Whenever we decide to conduct an observational or experimental study, we have to decide upon the sampling method, how we will pick the samples from the population. Now, the first method is simple random sampling method. In this, what happens that you take all the elements of a population and randomly pick the required number of samples from the population. The important point here is that each and every element of the population has equal probability of getting selected. So simple random population is picking up samples randomly from the population. Then there is the second method, which is called as a stratified random sample. In this, what happens, within the population you create homogeneous groups, and from that homogeneous groups you pick up your samples. So population is divided internally into relatively homogeneous groups or strata, and then random samples are drawn from that group. A good example would be, suppose you are going to test the efficacy of a drug on liver cancer patients. So you would like to divide the liver cancer patient into stage 1, stage 2, stage 3, stage 4, and then since this stage 1 group people of liver cancer will have similar characteristics, then you draw random samples from that. So this is a stratified random sample. Third is cluster sample. Now what happens that in many times in practical situations, the samples are distributed in a wide geographical area. So it is not strictly possible to go for random sampling. So this cluster sampling is when we identify clusters, geographical clusters, and then we take random samples from that. So basically random samples are drawn from clusters. A good example would be, suppose we want to check the effectiveness of immunization schedule. So we can divide the entire geographical area into various villages or blocks, and then we will draw random samples from each of these villages which are selected. Systemic sample is in which involves a selection of elements in some systematic way, like say every 5th patient, every 20th patient. So these are some of the sampling methods. Let's look at these sampling methods from an example point of view. Suppose there is a researcher who has to conduct a study of 100 medical students which are attending a conference, of all the medical students who are attending conference. Now the first way would be he collects the list of all the medical students who have attended a conference and randomly chooses 100 students out of it. So this is simple random sampling. Another method would be he divides the students into students from government college, students from semi-government college, students from private institutions. Now this division is because he feels that students from government college will have similar responses within themselves, which will be different from students from private institutions. So he divides the entire the population into homogeneous groups, and then random samples are chosen from them. The third way would be he realizes that there's 20 simultaneous sessions, and he chooses any 5 sessions, and in those 5 sessions he chooses any 20 students. So this is cluster sampling, where he finds easily accessible clusters, and among those clusters he chooses his sample. And finally he sits on the registration counter of the conference and chooses every 5th student who registers. So this is systematic sampling. So now let's move on to types of study. Types of study, essentially if you see, studies are of 2 types. One is experimental, second is observational. Experimental studies are those in which there is some kind of intervention brought in by the researcher. In observational studies, only the the sample is observed, and there is no active intervention in these kind of studies. Let's look at another important topic, that is types of bias. Now if you know, I mean, we have learned about bias in accuracy of an observation. So the first type of bias is assertment or detector bias, or it is also called as assessor bias. What happens is the bias which is because of the assessor is called as detector bias. Now, suppose a doctor knows that a patient, these group of patients are actually getting placebo, and these groups of patients are getting the medicine. Now, such kind of information at the doctor's end can actually lead to the bias in his observations. He may feel that the patients who is getting the actual drug is doing much better than patients who are not receiving the actual drugs. So such kind of bias in observation is called as detector bias or assessor bias. The second can be response bias. Response bias is from the side of the patients. Suppose patient know that they are getting the placebo or they are getting the medicine, and based on that, whatever bias is created in our observations, that is response bias. Third is allocation bias, or and these are generally due to the confounders. What happens is, while allocating patients, who are into case or control, whatever, if there is a bias, if there is a difference in the two groups while allocation of patients, then such kind of bias will become allocation bias, which means that while giving the patient, assigning the patient into case and control group, there is the case and the control group are not exactly matched. This will lead to allocation bias. Now, how can we reduce bias or confounders? There are various methods. First is randomization. Randomization means we randomly allocate patients into case or control. Second is matching. In matching, what happens? Each patient in the case group is matched with the control group. So there is very little allocation bias in such cases. Third would be stratified randomization or pre-stratification or blocking. In this, again, what happens is homogeneous groups are created and the patient is randomized into case and control. So, as remember earlier, we have given an example of liver cancer patients. So, stage 1 liver cancer, again, equal number of case and control taken from that. Restriction. In this restriction, there is participants are restricted according to certain characteristics. So there is some inclusion and exclusion criteria which reduces the confounders. And finally, there are various different kind of study designs which, like say, single blind study, double blind study, which further reduces the confounders. Moving on to various kind of study design, if we see experimental study design. So in this, what happens? Crossover study. In this, the first study is the crossover study. Crossover study, each group of patient act as their own control. So patient group A, in the first month, they, for example, they are receiving the drug. Second month is a washout period of the drug, and the third month, or they are receiving the placebo. So we can see the effect of the same drug in the same group of patient. So this is crossover study. Second, there are various non-experimental designs. The most important being cohort study or longitudinal or prospective study. Now, in this study, what happens is basically we focus on the factors related to the development of the disease, and it is used to study the natural course of disease, and it is very time consuming and costly. So it is not very useful in rare diseases. Example would be development of liver cancer in chronic alcoholics. In this, what happens? There is an exposure, or there are certain risk factors based on which the patient is selected as a case or a control. The study starts and the patients are observed for a very long period of time till the development of the disease. So we know, suppose a patient is a chronic alcoholic, so we put him in the study. We keep observing him till he develops or does not develop a liver cancer. So this is cohort study. So you can imagine the patient has to be followed for very, very long period of time, for 10, 12, 15, 20 years, for the study to complete. So it's a very costly study, time consuming study, and also it cannot be used for very rare diseases because the sample size would be not very sufficient. The next kind is case control or retrospective study. In this, what happens, as compared to the cohort study, it is fast and cheap and useful for rare diseases also. Now, in this, what happens, that the study starts currently, and then the researcher goes back and trying to find out a fact related to the exposure and the disease. So it's like this study moves backwards. So currently the patient is having that disease, and so the study is starting, and then we look behind the factor. A good example would be of such kind of study would be vaginal carcinoma in patient with disease exposure. There is something called historical cohort study or retrospective cohort study. Now, in this, what happens, again, the study starts in today. The study starts till today. But the difference from case control study is, in case control, not all the patient will have the disease. But in historical cohort, all the patient is going to have, 100% of the patient is going to have disease. And then we look backward to understand what are the exposure elements for development of those disease. Then there is case series studies, and you would be it is important because original work of AIDS just described 8 cases of Kaposi sarcoma. In this, what happens, again the study starts in today, but it is not like a case control study. So the study starts in the patient who have a disease, and then we look back for the history of exposure and other such factors. Then there is prevalence study. Prevalence study is also called as community service, and they are also called as cross-sectional studies. So again the study is starting here in today, and then we look for exposure and disease. Now you have to understand the major difference between prevalence study, that is cross-sectional studies, and longitudinal studies. Cross-sectional studies, what happened, it is the prevalence of a disease at today, at a point of time. But longitudinal study is basically how disease develops over a period of time, right? So this is why this is called as cross-sectional, and the that study is called as longitudinal studies. Now, there is something called as ecological studies. Ecological studies is when the data is collected of the whole population of the community and analyzed at that level. Example would be incidence of depression in people who own car. So we do not segregate anything. We do not go here. We just relate one parameter to another. Incidence of lung cancer with pollution level. So such are the studies which is ecological studies. Then one of the most important study is post-marketing study. This is also called as phase 4 pharmacovigilance. Now, all these biostat or whatever concepts we have learned about sampling and observation or various kind of study design, they are all based for evidence-based medicine. Now, evidence-based medicine is what, in which actual evidence rather than opinion must be of primary scientific basis for making clinical decisions. So anyone's opinion is not considered. It's just the data which we consider. This is very important because opinions, one person can see only a few cases and the opinions can be biased. They may not be accurate. But once we conduct a study and use the evidence from that, the actual data from that, the chances of biases actually reduces very much. So the method used is called as PICO method. PICO is P stands for participants. Who are the participants? So for any evidence-based medicine, because as you move forward, a lot of this term will come, a lot of data will be given to you that so and so drug is better in so and so patients. So you have to understand that who were the participants of that study. So what was the intervention? What was the comparison? What it was compared with? What was that comparison with a placebo, or was the comparison with the existing drug which is being used? And finally, what is the outcome? What is the outcome? Is it is the new drug better than the placebo? Is the new drug better than the current gold standard? Is the new drug similar to the current gold standard? So this is the PICO based method for evidence-based medicine. Who are the participants? What is the intervention? What is the comparison? And what is the outcome? Now, when you will be getting into clinical, there will be a lot of evidence being presented to you, but you have to understand that all evidences are not same. So you have to rank them, and you have to be very, very sensitive while using information in terms of evidence. The top of the hierarchy is evidence synthesis. Then comes the importance of experimental data, and non-experimental data is given the least importance. Now, if you see evidence synthesis, there are two kinds. One is meta-analysis, second is systemic review. We will talk about both of them. Then experimental data, both RCT, randomized controlled trials, and non-RCT, non-randomized control. So whatever experimental data is will be given the next level in importance, and the lowest in importance will be case series, case reports, expert opinion, in vitro data, cohort studies, case control studies. So these are non-experimental data. And so now, evidence-based medicine, systemic review is the objective study based on all good quality study done in a particular area with goal of enabling clinical decisions. So that is systemic review. Method is, we define a clinical situation, we study reviews with meet specific inclusion and exclusion criteria, we search literature to find all relevant studies, which includes foreign language study, gray literature, and even unpublished data, and then data from all the various experiments is extracted and analyzed. So this is systemic review. Suppose you want to understand whether use of aspirin in patient with cardiovascular disease reduces the mortality and morbidity. So we can create a systemic review on that, because this is a clinical situation, and then we can study all the various research which has been done on this and understand, get the data from all the research and get a huge amount of insight on this particular topic. So this is systemic review. Now meta-analysis is where you actually take just the data. So we do a meta-analysis in systemic review also, and what happens is we take different, like say effect of statins on cholesterol. So there will be a lot of different studies on that. When we combine all those studies, what happens is the sample size increases, so it increases the power of the analysis and also reduces the type 1 and the type 2 error. Plus, since this meta-analysis, the different studies are in different parts of the world, the data or the outcome of the meta-analysis can be more generalized, and as these studies have been done across multiple geographies and population. The results of meta-analysis is generally shown as a funnel plot and a forest plot. So this is example of a meta-analysis. In this again, the favor of use of statins in cardiovascular disease. So what happens? The center line is what it shows is the risk ratio, or the basically 95% confidence level interval. This is individual study, what was the result, and the size of this square will tell you how big that study was in terms of population, and finally this will show you the overall result. So in this case, the overall result favors statins. So this is something we will learn more about it when we are finally looking at research works. Now, evidence-based medicine is basically what we try to look at is, we try to look at efficacy, that can it work, versus effectiveness, does it work in the real world. We looked at the cost effectiveness of the therapies, and we look at causality indicators. When you are doing a research, anything could be related to anything, but establishing a causality indicator is very important, which can be dependent on strength of association, like how closely or how closely the two indicators are associated. Then reproducibility, which means in every experiment if the same kind of result is produced. Specificity, which means that if one changes, then only the other changes. Temporal relationship, which means time relationship between various parameters. Biological gradient or dose response relationship. Suppose we want to measure that, okay, with the increasing dose, the effect of that medicine is increasing, or with decreasing dose, the effect of that medicine is decreasing, then we can say that the effect is because of the medicine. And plausibility, which means that fits common knowledge. So all these things, suppose, and it is very important, because you may give a drug to a patient who is under observation, and the blood pressure may decrease. You may assume that the decrease in the blood pressure is because of the drug, but it may be that simultaneously he has started changing his lifestyle, or simultaneously he has started taking less salt, or simultaneously he is more vigilant on various other activities. So is the decrease in blood pressure because of the drug or because of his lifestyle changes? If you want to establish that, then these causality indicators will be very, very helpful.